Synthetic dyes. Part first. In this lecture, we will see the introductory section of the chapter, that is synthetic dyes. So, this is the content of the chapter. First one, we will see introduction and qualities of good dye, then classification of dyes based on constitution, and another classification which is based on methods of applications. Then we will see Witt's theory and synthesis of these three dyes, that is orange fourth, malachite green, and phenolphthalein. This is the syllabus of this chapter, synthetic dyes. So let us start with the introduction. Dyes are colored organic substances having a property of imparting their color to other substances like fibers, leather, paper, foodstuffs, hair, photography, etc. Dye must impart permanent color and it should not be removed by washing with water, soap, detergent, or even when exposed to sunlight. At one time, all the dyes were obtained from natural sources. And alizarin, indigo, these are the classical examples of natural dyes. The first synthetic dye stuff was prepared in 1856 by 18-year-old Englishman W.H. Perkin. While studying the action of oxidizing agent, that is K2Cr2O7 potassium dichromate with sulfuric acid H2SO4 on crude aniline to synthesize quinine. Instead of quinine, he got black resinous mass from which lilac colored matter was obtained. He purified resinous mass and Perkins violet dye, commonly known as Maua dye, obtained. As the Germans were pioneer in the field of dyes, most of the dyes were sprayed in German. Later on, several countries like United States of America, Switzerland, UK, Japan, and Italy are entered in this field. Hundreds of dyes are being produced nowadays by synthetic means in the laboratory. Modern materials can have as many as 70,000 shades, more than 120 reds, 50 yellows, 145 blues, and 70 browns were synthesized. Tremendous progress has become possible because the relation between color and constitution were known and it has been studied well. So let us see what is the relation between color and chemical constitution. Most of the dyes are aromatic in character, but only some aromatic compounds act as dyes. For example, this is benzene, and we know benzene is colorless. This is nitrobenzene. We know the color of nitrobenzene is pale yellow, but this is not a dye. And this structure is picric acid. This is a dye and yellow colored dye. The relation between these three structures, that it has only benzene ring, there is addition of one NO2 group over benzene ring, and here 3 NO2 are on the benzene ring as well as one OH is present on the benzene ring. So something is there, the factor which brings color to the compound, and apparently we can think about that NO2, introduction of NO2 may be responsible for imparting color to this picric acid. So let us see what is the actual reason. From above example, it is clear that color of compound is related to chemical constitution. Benzene is colorless, but nitrobenzene has pale yellow color. Nitrobenzene possesses pale yellow color due to NO2 group, presence of NO2. Therefore, nitro group is responsible for color of nitrobenzene. The reduction of colored organic compound result in the loss of color, and oxidation of reduced compound regenerates the original color. And this has been first put forth by Gravy and Lieberman in 1968. So relation is when any colored organic compound is reduced, that means hydrogens are added. That means double bond or multiple bonds are eliminated, then the compound becomes colorless. But when this compound oxidized or H2 are removed, or we can say double or triple bond, multiple bonds are added, then that colorless compound become colored. So reduction makes it colored, and oxidation, reduction makes it colorless, and oxidation makes it color. The unsaturation is responsible for development of color. Remember, unsaturation is responsible for development of color. So what is chromophore? It is an unsaturated group present in organic compound which is responsible for color of the compound. This is the Greek word. Chroma means colors and phorus means bearing. Colors bearing group, that is chromophore. Some important chromophores are nitro, azo, carbonyl, azomethine, paraquinoid, ethylenic, nitroso, azoxy, thiocarbonyl, azoamino, and orthoquinoid. These are some of the important chromophores that are responsible for the colors of those compounds. Then what is meant by oxochrome? A dye is a chromogen containing second group called oxochrome, which deepens the color and also fixes to the substrate. These groups are salt forming groups, may be acidic or basic in nature. Some of the oxochromic groups are listed. These are amino, then dimethylamino, carboxylic acid, chloro, methoxy, acetyl, methylamine, hydroxy, sulfonic acid, methyl, cyano, and amide. These are some of the important oxochromic groups which deepens the color and also fixes that color to the substrate. And deepening of the color is change in color from yellow to orange to red to purple to violet to blue to green to black. And the deepest color is black color. Then what are the Qualities of good dye. Qualities of good dye depends on its properties and its practical utility. A good dye must fulfill following requirements or conditions. And first one is the dye must have attractive color. First and very important property or quality of the good dye is it must have attractive color. Second one, it must be permanent, able to fix itself to being fixed to substrate. It should not be affected by water, soap, acid, or sunlight. Third property is it must be cheap and easy to handle. Fourth one, it must be easy to dye, that is easily soluble in the solvent. It must form stable and good dispersion in water. Fifth property is it should not be harmful to skin or body. That is, it must be user friendly. Then let us see nomenclature of dyes. Chemical names of dye are complex due to their complex structure. Therefore, generally, the trade names are used along with capital letters to indicate the color shade, their nature, property, etc. But no systematic method has been employed in naming dyes. The deepening of the color is indicated by repeating the letters several times. The letter have other meaning. Letter D stands for direct dye. F stands for fast to light, etc. So G stands for yellow, R for red, B for blue, S for acid. Actually, S stands for sour. Sour means acidic, and S indicate acidic dye. O for orange. F for fast to light, D for direct dye, W E for fast washing, and I for wet dyes. So these are some of the letters used with the name of dye. To avoid these difficulties, the Society of Dye has prepared a color index in which each dye is given its color number. So CI 1012, CI 1210, CI 1220, etc. Rhodamine B. This B stands for blue. Acridine orange R. R stands for red. Indanthrene GK. This G stands for yellow and K stands for dyeing in cold. Alizar in red. This S stands for acidic dye. And fast yellow G. G stands for yellow. Let us see classification based on constitution and methods of application. And the first basis of classification, that is the constitution. Dyes are classified in different ways according to their chemical constitution, methods of application, types of materials to be dyed, the intermediate from which they are prepared. These are the number of um, different bases on which the dyes are classified. But for our syllabus, only two bases are there, that is depending on the chemical constitution and methods of application. However, first two classifications of dyes are very important and these are for our syllabus. So first method is classification of dyes based on chemical constitution. So first type or class of the dye, that is nitro dyes. So these are the example: picric acid, Manchester yellow. Compounds containing NO2 group are known as nitro dyes. So nitro group containing dyes are nitro dyes. Then nitroso dyes. NO group containing dyes are known as nitroso dyes. These are the some examples. gamba in R, gamba in Y, fast green O. Then third one, azo dyes. In azo, two subtypes can be there, and that monoazo dyes and bisazo dyes. So azo dyes means those dyes which contain N double bond N, this azo group. If only one azo group is present in the dye structure, then that dye is known as monoazo dyes. Methyl red, methyl orange, these are the monoazo dyes. Bisazo dyes, these are the compounds which contain two azo groups. And as this bis also indicate, it has plane of symmetry, mirror plane of symmetry, and it has symmetric structure. So bis azo dyes are symmetrically structured azo dyes with two azo groups in this structure. So Congo red and Bismarck brown, these are the examples of bis azo dyes. Fourth one, triphenyl methane dyes, that is TPM dyes, and this contain central carbon with three phenyl rings. These phenyl rings sometimes may be aromatic and sometimes may be non-aromatic. But the condition is central carbon with three phenyl rings. These dyes are known as triphenyl methane dyes. Para rosaline and malachite green. These are the examples. Anthraquinone dyes, the structure in which two phenyl rings with central six-membered ring and two carbonyls, that is quinoid structure. These dyes are known as anthraquinone dyes. So alizarin and alizarin orange A, these are the examples. Indigo dyes. Indigo dyes are those dyes, and in their structure there is six-membered ring with five-membered ring containing one nitrogen. These are known as indigo dyes. Indigo, blue vat, and royal purple, these are the examples of indigo dyes. Thiazine dyes. Thiazine dyes are those dyes which contain six-membered ring with nitrogen and sulfur. Other structures may be different in different dyes. Phthalene dyes. The phthalene dyes contain the structure that is resemblance with phenolphthalein, which contain central carbon with 3, similar to TPM. But here, this phenolphthalein is the special structure which is synthesized by reaction of phthalic anhydride with two molecules of phenol in presence of acid. Phthalocyanine dyes. This is the structure. Porphyrin rings are there. Central copper is there. These structure containing compounds are known as phthalocyanine dyes. Stilbene dyes. Stilbene dyes are aromatic rings with carbon-carbon linkage linked with another aromatic ring. These are stilbene groups, and stilbene groups containing compounds are known as stilbene dyes, which are colored. Xanthine dyes. Xanthine dyes are, this is the xanthine moiety. So three rings are there. Central ring with one oxygen. These are known as xanthine dyes. Sulfur dyes. Sulfur dyes have carbon sulfur and carbon linkage as a chromophoric group. These have complex structures. These dyes are insoluble, cheap, and good fastness to washing and light. These dyes are popular because they are heavy shades such as blue, green, black, brown. 13th type, that is pyrazolone dyes. This is the core moiety. This five-membered ring with two nitrogens. If this is the core structure in any dye, those dyes are known as pyrazolone dyes. Thank you.